Hi guys! Today in class we covered graphing a polynomial, both factored and non-factored. In this video I'm going to show another example of graphing a non-factored polynomial. I'm also going to show you how to convert from factored form into standard form. But in this first example I'm going to go from standard form into factored form. So let's look at an example. So in this example, we have a quartic function, and I know it's a quartic function because of its degree being 4. Okay. I can also see that it's in standard form because I have all my like terms combined and it's in descending order from the quartic term, then the cubic term, then the quadratic term. So this is in standard form. And before I even start graphing it, I know that its degree is 4, and that helps me with the end behavior as we discussed in class today. Whenever there's an even end behavior, or an even degree, I should say, the only options for end behavior are up, up, or down, down. Because the lead coefficient is positive in this case, we know our end behavior is going to be up, up. I can also see from the equation, because it's in standard form, that the y-intercept is 0. And I know that because there's no constant term at the end. It's as if there's a plus 0 sitting at the end. So I already know my y-intercept. Okay, so since this is in standard form, I cannot look at it and see what the x-intercepts are. In order to do that, we're going to have to factor this. So the first thing you want to do when you have to factor is to see if there isn't a term that you can take out of every single term. And in fact, there is a term that I can take out. I can take out a 2 from every one of my coefficients and an x squared from each of the variable terms. So if I take out 2x squared, I will be left with, inside the parentheses, an x squared term for my first term, a 2x term for my second term, and just a constant 8 for my third term. So I've already started factoring this. In fact, this is one of my factors. But I could continue factoring this quadratic, and you guys are excellent at factoring quadratics, and so hopefully you'll be doing this before me, that this factors to x minus 4 and x plus 2. So maybe pause the video at this time to catch up in your notes, because you should be taking notes on everything you see in this video. Okay, now that I have my 3 factors, 1, 2, 3, I can set each of these factors equal to 0 to find the x-intercepts. So remember, whenever you want an x-intercept, you're technically letting y equal 0. So that's what we're doing in this function. But I'm going to just let each individual part equal 0. So I'm going to say 2x squared equals 0, and to solve this I would divide both sides by 2, and then take the square root. So whenever I divide by 2, I get x squared equals 0, and so x here would equal 0. That's one of my x-intercepts. I actually already knew that from the fact that the y-intercept was 0. That means the x also must be 0. I'm then going to set this factor equal to 0, technically, and when we do that, we would get that there's an x-intercept at x equals 4. So that's a second x-intercept. And I'm going to set this factor equal to 0, and so my third x-intercept is at x equals negative 2. So now I have my x-intercepts. Earlier we found our y-intercept and the end behavior. So we're pretty far on our way to graphing this. The only other thing worth noting is that this 0 here, maybe I should change the color here so it stands out a little bit. This 0 here has a multiplicity of 2. A multiplicity of 2, and today in class we discussed that that means that this 0 is going to be a bounce point. So now let's get started graphing this. Alright, so I've set up my axes over on the right, and I'm going to graph my y-intercept, which also turns out to be my x-intercept. I guess I should change the color here again. Go back to red. So my y-intercept is at 0. And then that takes care of this x-intercept here, but I also have an x-intercept at 4, and another x-intercept at -2. So just as we discussed in class today, we're going to want to put in our end behavior at the ends of the graph. Well, since this is my first x-intercept here, that's one end of the graph. Before this point, I know that the graph must have been going up. And over here at 4, that's my last x-intercept. So I know after this point, the graph must, again be going up. So back to our multiplicity of 2 here on this 0, which is this one right here. I know that this 0 is a bounce point. So I'm just going to write in here that this is a bounce point. That's my little note to myself, although I'm just recognizing it's going to be in the way when I draw my graph. But we'll cross that bridge when we come to it. Okay, so this is my bounce point, which means that my x-intercept at -2 is not a bounce point. So I'm going to go through the x-axis there. At some point, I'm going to have to turn back around to get up to this x-intercept here, but I'm going to bounce off. Okay, and I'm going to go down. Since I have more room between these x-intercepts, I'm going to go down further. And then I know I have to turn around to get back up to that x-intercept at 4. So here is my best effort at this quartic polynomial. Again, you might want to take a minute to pause the video so that you can make sure that everything you see on this screen you have copied in your notes. And if there are any questions, you could always rewind the video to listen to me a second time. But at this point, I'm going to move on to the last part of the video, which is that I want to convert a polynomial from factored form into standard form. And just one last thing here, you'll notice that in this video, I went from standard form, right here, into factored form. I ended up factoring this, although I could have written in here y equals 2x squared again. So this is factored form, and again, this is standard form up at the top. Okay, so on the next slide, I'm going to go the opposite direction, from factored form into standard form. So once you're ready with this, you can press play again on the video. All right, so here is our example of converting from factored form, which is this, into standard form, which we're going to do now. You'll notice, hopefully, that this is a cubic function because I have an x here, and technically over here I have an x squared term if I were to expand it out. So this is in fact a cubic, which we'll be able to see once we get it into standard form a little easier. So for me, I'm going to start converting this by expanding this binomial here, which right now is being squared. And we've done a lot of that. Maybe you want to go over to the side of your paper. It's x minus 2 times x minus 2, remember. We will not be distributing the exponent into this set of parentheses because there's a subtraction sign in between. So no distributing that exponent. In fact, you have to double expand this out, or some of you like to call it foiling it out. And that means that I'm going to take my first term and multiply it by both terms, and then I'm going to take my second term and multiply it into the parentheses. So when we do that, we would get x squared minus 2x, which a lot of us are doing that in our heads, plus 4. So this, once we combine our like terms, I'm going to move it over here now, becomes x squared minus 4x plus 4. So that's that part, but don't forget that I still have this x plus 3 on the left. So now what I need to do is I'm going to double expand again, except that it's kind of a lot of work, because I'm going to have to take this first term here, the x, and I'm going to have to distribute that into this set of parentheses 3 times to this term. I'm going to have to distribute it to this term and to our final term, and multiplying as I go. So we get y equals x times x squared would be x cubed, x times negative 4x would be negative 4x squared, and x times 4 would be 4x. So that's the first term distributed in. Then I'm going to have to take the second term, which in this case is positive 3, and I'm going to have to distribute that into the parentheses 1, 2, 3 times. So when I do my first term, I get a positive 3x. Sorry for the change of colors here. Sorry, positive 3x squared. And with my second term, I get minus 12x when I multiply. And for the third term, I get plus 12. Now remember, when you're in standard form, you're supposed to go in decreasing order, and I'm supposed to combine all my like terms. So I do have some like terms here. Let's see, we have a minus 4x squared term and a positive 3x squared term, so we'll be combining those. There's nothing for me to combine this with, so I'm going to rewrite it. Y equals x cubed. And then I'm going to combine these two, as I said. Negative 4x squared plus 3x squared is negative x squared. I can also combine 4x with negative 12x. That's negative 8x. And my last term over here, the constant term, does not have anything to be combined with. And so this has now been converted into standard form. As I said at the beginning, it's a cubic. Okay, and now we can see the y-intercept is 12. We could have also figured out the y-intercept by, up here, putting in 0 for each of the x's. If we put in 0 for each of the x's, that would have been 0 plus 3 here, which would be 3, and 0 minus 2 here, which would be negative 2, but when I square it, I would get positive 4. And so 3 times 4 would give me my y-intercept of, back down here, 12. So that's converting from, and it's getting very messy here, from factored form, which is this again, into standard form. Hope you found this video helpful. See you guys tomorrow.